So another topic to continue about the continuity of a function is the continuity on an interval. A function can be continuous on interval. This simply means that it is continuous at every point on the interval. Equivalently, if we are able to draw the entire graph of the function on an interval without lifting our tracing pen or without being interrupted by a hole in the middle of the graph, then we can conclude that the function is continuous on that interval. But if there is one point in which the domain of x is discontinuous or interrupted, therefore the whole um, interval of the function is continuous. Discontinuous, rather. If in the limits we have what we call one-sided limits, here in the continuity we have also this one, what we call the one-sided continuity. A function f is said to be continuous from the left at x is equal to c if the f of c is equal to the limit of the function to the right, to the left, I mean. A function f is said to be continuous from the right at x is equal to c if the f of c is equal to the limit of the function to the right. Now we have the following example to determine the continuity on an interval. Okay, for this example, we will determine if the following the function f is continuous on the following interval. The first one is from -1 to 1. The next one is -infinity to 0. And number 3 is from 0 to +infinity. Do not be confused about this interval. It is not the same with the point at x is equal the x and y coordinate plane, which is from -1 and 1, also known as at this part of the Cartesian plane. No, it's not. So we are talking about the interval, which it means the -1 means this this comes from or will start from x sub 1 and will end at 1. So this is also an x, which is an x sub 2. So it means that we will start to evaluate the continuity in a function on an interval from 1 up to, from -1 up to 1. So at this point on the graph to this one. Now we will trace the graph from the right side of x is equal to -1 to the left of x is equal to 1 without lifting the pen we are using. Thus, we can say that the function is continuous on an interval -1 to 1. So the answer on that certain interval from -1 to 1, our function is continuous. Okay, for number 2. Okay, we will start to evaluate at -infinity and we will end to 0. So this is the x sub 2 at 0 and the x sub 1 is -infinity. So we will stop from the bottom and then we will trace the graph up to x is equal to 0. Now there is no interruption and we did not lift our pen, therefore our function is also continuous at this point. For number 3, we will start at the right side of x is equal to 0 to infinity. So we will trace the graph to +infinity. There's an arrow here, so it means it is continuous up to the +infinity. So there is no interruption here. We did not lift our pen, therefore our function is also continuous on an interval from 0 to infinity. Okay, another example here to determine if the function is continuous on the interval from -1 to 1 and from zero point 0.5 to 2. Now, we will start at -1, which is here or at this point on the graph, and we will end at x is equal to 2, which is at this point on the graph. If we trace the graph of the function from the right side of x is equal to -1 to the left side of x is equal to 1, we can see that there is an interruption here because there is a hole at x is equal to 0. Therefore, we are forced to lift our pen because of this interruption just before we reach x is equal to 0, because it indicates that the function is not defined at x is equal to 0. So we can continue our tracing, or we can start again from the right of x is equal to 0. So since there is an interruption at x is equal to 0, and we know that at least one disruption on an interval, therefore we could conclude that the whole interval is discontinuous from -1 to 1. Okay, for number 2, from 0.5 to 2. So the 0.5 is somewhere from here. So we will start at 0.5 and we will end at x is equal to 2, so which is here. So as we trace the graph of the function from the right side of x is equal to 0.5 to the left side of x is equal to 2, we could see that it is so smooth to trace the graph. There is no interruption in anywhere in between, and therefore our function is continuous from 0.5 to 2. Okay, another function here. We will determine if the function is continuous in the following intervals from -1 to 1. So we will start at -1 and we will end at 1. So as we trace from the right side of x is equal to -1, we could see that as we trace it, we would have an interruption at x is equal to 0, because at the left side of x is equal to 0, the graph is going downward indefinitely. And right after x is equal to 0, we will start from the positive infinity, and as we trace, going to x is equal to 1. So since there is an interruption at x is equal to 0, therefore our function is discontinuous on the interval from -1 to 1. Now for number 2, we will determine the continuity from 0.5 to 3. So we will start from